Okay, so we're back to some trig, and today we're going to talk a little bit more about the circular trig and how that helps us solve different problems. And so we stopped here at looking at these two triangles, the 45-45-90 triangle and the 30-60-90 triangle. And so now we want to see where these help us figure out points along the unit circle. Remember that ordered pairs here on the unit circle, xy, can also be written as cosine theta, sine theta, where the theta is the angle, it's the central angle here that's made with the positive x-axis. Okay, so that's your theta. Okay, and so if this is the unit circle, then this has radius 1. Good. So now I think we can figure out what our cosine and sine will be for all these different angles. So if we start here at 0, the coordinates are 1, 0. And so that tells us that the cosine of 0 is equal to 1 and the sine of 0 is equal to 0. Good. Now we go up excuse me, 30 degrees to pi sixths. And so we're going to use our triangle here. And I see that the cosine is a square root of 3 over 2. And then the sine is 1/2. So those are the coordinates on the unit circle. Excuse me, I need something to drink. Okay, so now we're up to pi over 4. So we go up to the 45-45-90. And I see 1 over the square root of 2 there is my cosine. Same thing for the sine. So that puts us at 1 over the square root of 2, comma 1 over the square root of 2. And finally, for pi over 3, I'm looking at this triangle again. That's right here. And so that's 1 over 2 and square root of 3 over 2. Very good. And so now at pi over 2, we have 0, 1. And now, if you see here that we know the cosine of all these different angles. 0, pi over 6, pi fourths, pi thirds, pi over 2. And so now if I take and I go 30 degrees more, pi over 6 more from pi over 2, I get to 2 pi over 3. And then if I go down 45 degrees more, I get to 3 pi over 4. And then, oops, I lost my dot here for 5. This is pi minus pi over 6, which would give us 5 pi over 6. And now we can figure out what the sine and cosine are for each of those angles just by flipping these coordinates in the quadrant 1 over to quadrant 2. So if I'm here at 2 pi over 3, that means that I'm just flipping this point over to here. And so this is going to be minus 1 over 2 square root of 3 over 2. Right, so that means that the cosine of 2 pi over 3 is minus 1/2, and the sine is square root of 3 over 2. Good. Similarly, you can do the same thing for the other points. So here at 3 pi over 4, we get that. Then we can do the next one as well, and the next one. Good. And then we could do the same thing down in this quadrant and down in this quadrant. I'm going to leave those open for a second and let you look at those. We're going to try working through some problems to see how the unit circle can help us. Good. So let's try one first here. Example 1. Suppose that I know that the tangent of some angle is equal to 2, and I know that the angle is in which quadrant? Quadrant 3. Quadrant 3. Find the other 5. Find the other 5 trig functions. Okay. So before we start, let's see, if tangent of alpha is equal to 2, then what does that tell me about the triangle that I'm on? oops, it tells me that tangent is opposite over adjacent. So therefore, if this is alpha, opposite would be that number and adjacent would be that number. And so this would be the square root of 5. Good. And so now I need to figure out the sign, S-I-G-N, of each of these numbers. So if I go up to the unit circle, if I'm in quadrant 3, where am I? This is quadrant 1, this is quadrant 2, this is quadrant 3. In quadrant 3, both sine and cosine are negative. In other words, in my triangle, that means this is negative and this is negative. Right? And so your tangent of alpha is actually -2 over -1. Okay? But now given this, we can now create our or evaluate our functions, sine, cosine, tangent, and then we have cosecant, secant, cotangent. Okay, we know tangent is 2, so we know cotangent is 1/2. And now we fill out the other ones. The sine is going to be -2/5, or 2 over the square root of 5. Cosine is -1 over the square root of 5. And then these are just the reciprocal. Good. That's all there is to it. Easy. Easy and fun. Let's try another example. Find all x such that 2 cosine of x plus 1 is equal to 0. All right. So first off, let's just go ahead and solve that algebraically. Oops, sorry about that. We have 2 cosine of x plus 1 greater than 0. Oops. I wanted that to be greater than 0. Sorry about that. So then cosine of x will be greater than -1 over 2. So if we think about where we are on the unit circle, I need cosine of x to be greater than -1/2. So if I go over here to -1/2, right, I'm looking for points on the circle for which the x-coordinate is bigger than -1/2. So that puts me, puts me here and puts me here. Now, what are those values? Well, this is where we would need to remember our unit circle, because if we're at -1/2 and -1/2, can we fill in the y-coordinate? I think we can. I think it's square root of 3 over 2 and minus the square root of 3 over 2, and that's 2 pi over 3. So here we would have square root of 3 over 2, which tells me that this angle right here is 2 pi over 3. And then this one, minus square root of 3 over 2. Let's see, this small angle here is pi over 6. So this angle here is 3 pi over 2. So what is, I'm going to make a side note. What is 3 pi over 2 minus pi over 6? Multiplied by 3, 9 pi minus pi over 6, 8 pi over 6, 4 pi over 3. So that is 4 pi over 3. Oops. Oh no, my circle went away. Okay, that angle is 4 pi over 3. Good. And so we see now, I better be careful here. The angle measure from here to here is 4 pi over 3 from here to here. But if we go in this direction, that's a negative 4 pi over 3, right? If I go this direction, that would be 2 pi minus 4 pi over 3, which is 2 pi over 3, right? So, oops, wait a minute. 2 pi, is that right? Ooh, let me correct that real quick. So, this is actually positive 4 pi over 3, right? And or you could write 4 pi over 3 is actually the same thing as minus 2 pi over 3, right? Depending on how you want to measure the angle. Okay, so then we could write down our x then. X is either between, oops, not equal to 0 and 2 pi over 3 on the positive side here. That's this part. And then it's also, we could take 4 pi over 3 to 2 pi. So that would be this part. Good. I've gone way over time, so I'll stop there, and then maybe I'll do one more video where we just do a few more exercises.